In May, members of the Yellowstone Volcano Observatory gathered for a tabletop simulation of volcanic unrest, practice for the kind of activity that might someday present a public safety hazard.
So there's a variety of hazards that could impact the Yellowstone region in terms of geologic events. The thing that maybe most people are familiar with are these catastrophic huge explosions, right? This is what Yellowstone is sort of known for. Those are extremely rare, and we don't have any evidence the magmatic system right now is even capable of such an event. Less impactful than that, but a little bit more likely, are lava flows. There have been several dozen lava flows in the caldera since the last huge explosion at Yellowstone. So they're still not that normal. The last one was 70,000 years ago. Slightly more likely than that is a strong earthquake. Now, the best example of this is perhaps the magnitude 7.3 event that occurred just west of the park in 1959, the Hebgen Lake earthquake. And we can also have hydrothermal explosions. These range in size. Some of them are quite small. You might leave a crater that's a few feet across. Pork Chop Geyser in 1989 in the Norris Geyser Basin exploded, left a small crater. That's an example of a small hydrothermal explosion. But there are also some of the largest known hydrothermal explosion craters on Earth. In Yellowstone, Mary Bay on the north side of Yellowstone Lake is over a mile across. And that is an example of a hydrothermal explosion crater. So there's a variety of hazards, and any one of these might constitute sort of a geologic event that we would need to respond to as the Yellowstone Volcano Observatory. The Yellowstone Volcano Observatory is sort of unique in the volcano observatory system in the United States because it's a consortium of institutions. It's not just the U.S. Geological Survey. And we're all equal partners in trying to better understand how Yellowstone works and monitoring hazards and trying to communicate that information to the public. That diversity of skills, that diversity of institutional styles is really a strength.
So this tabletop exercise is a scenario in which we pretend that volcanic activity is occurring in Yellowstone, in the national park, in order to allow the Yellowstone Observatory, the USGS, and all of their partners and the Park Service to imagine how they would respond to what's happening during that volcanic unrest.
And so the point of the exercise today was to sort of get everybody on the same page for what it would be like if a volcanic event occurred somewhere in Yellowstone National Park, even a small one, which of course is the most likely scenario if magma were ever to reach the surface. How would the different agencies respond? How would we handle interacting with the National Park Service? How would we work within the incident command system that would be started to manage the park resources and visitors that might want to come in and that sort of thing?
The USGS runs these on an intermittent basis. The last one that we did was a tabletop exercise just for the USGS about Long Valley, which is a caldera system in California. Before that, we've done other scenarios. They've been done in the Cascades, for Mount Hood. So as many places as we can because each volcano is unique.
Yellowstone is incredibly active geologically. There's thousands of earthquakes every year on average. The ground is going up and down. There's gases that are coming out all over the place. There is hot ground in places, right? Geyser activity. So just because, say, one geyser comes back to life, that's really not anything different for Yellowstone. Just because there's a seismic swarm, that's sort of normal activity for Yellowstone. But by studying that, we can get a sense of when it's not normal and when it might require more attention from geologists, from geophysicists, from geochemists, to try to understand what's happening beneath the ground and whether or not this may culminate in a hazardous event.
Behind me here is an example of one of the GPS stations in the park. This is station P711. This can resolve its position to within about a centimeter, and that means that it allows us to track changes of just a few millimeters per year in the horizontal direction. So this means we can measure not just sort of the plate tectonic motion in this region, but also vertical movement, and that's really important here in Yellowstone.
So I work for the University of Utah Seismograph Stations. It's part of the Department of Geology and Geophysics at the University of Utah. And we actually own and operate the seismic network in and around Yellowstone. And all that data is telemetered out of Yellowstone in real time back to the University of Utah, and it goes into our sophisticated earthquake monitoring system that locates, identifies, gets magnitudes of earthquakes, and then sends out real-time alarms to duty seismologists. We average about 1,500 to 2,500 earthquakes a year in the Yellowstone region. Those magnitudes range from less than 0 to, occasionally magnitude 4, magnitude 5. Yellowstone's very interesting in that it's kind of a volcanic environment imprinted on a tectonic regime, basin and range tectonic. So we have those kind of two different geological processes occurring. So one thing that we're trying to do is, we have this cluster of earthquakes occurring. Is this related to tectonics or is this related to the volcanic system?
I'm interested in looking at where all the thermal areas are in Yellowstone. Geysers and hot springs and mud pots and gas vents, which we call fumaroles. And there are thousands of thermal features that are spread out over a huge area. And so one of the best ways, really the best way to keep track of these things is using remote sensing tools. They basically measure light that we can't see to see things that we can't see. Heat, in other words, heat being radiated by warm things. There are hazards associated with these thermal areas, such as stinky sulfur gases coming out of the ground, and the ground can be unstable. It's boiling just beneath the surface, and so you do have to be careful where you walk. If people step off trail, their foot can break through a crust into boiling water or steaming area. That's why they have the trails and boardwalks there.
I think one of the immediate takeaways from this exercise is the importance of tailoring the response to the event. We have preliminary hazards assessments for the Yellowstone area, but they have to be generalized because there's a lot of potential geologic hazard. The general is good, having that backbone is good, but any future event response is going to require a more focused, a more specific hazards assessment for the style of the activity and the location that we're seeing it happen.
It's always useful to think about these different scenarios, right? And kind of go through kind of what our day-to-day activity is about how we monitor Yellowstone, and then go through and how can we kind of tweak that to look at maybe some other things that we talked about in this scenario.
It was very valuable just to having everybody in the room together, interacting and talking and sharing their expertise and knowledge with each other. That was really, really valuable. That's what has to be done in a response like this. Everyone has to work together and communicate a lot with each other.